Yeah, welcome back. Well, I had a session in the same room this morning together with Waldo, and now on my own. Completely different topic about HTTP communication. Yeah, what can I say? There's actually a lot to tell about HTTP communication. I seem to have this topic around HTTP or web services and API quite sometimes. The purpose of this session is to dive into the HTTP client and everything around it, a number of best practices, how do they work, have some focus on, well, why do that? Just the next one, agenda. The default pattern for the HTTP client, so how do we call and how do we handle the exceptions that can happen. What is actually the difference between a get, post, the patch and a send command, because they are different, but why and how. I want to dive into HTTP headers because I see a lot of people struggling with setting headers at the correct level. We can set them at 3 different levels. Why do you set them on the HTTP client or on the request message? And what about the content type header? That is on the content, HTTP content. Why actually do we need to remove the content type header every time we want to change it? Why is it there to begin with? I hope to explain that. I want to talk a little bit about performance with the HTTP client. It's a heavy object that takes really some time to load. So what can we do about it? Then some best practices. How do we design our code when we work with the HTTP client? What should you do? What should you not do? We have the new REST client module that was introduced in version 23, which actually takes away a lot of the stuff that I talk about. Maybe I should only talk about the REST client and then probably you can skip a lot of the content that I have before, but at least then you understand what's going behind the scenes. And then I'll end with, if time permits, with some new developments that I'm working on, endpoint and OAuth management that should actually extend that REST client module. What is the agenda? A little bit challenging. I have actually no idea if I can manage that in 90 minutes. Maybe I need more, maybe less. Only thing I realize is that I'm between you and a beer, so I keep that in mind. Okay, so the default pattern for the using the HTTP client. The commands that we have on the HTTP client to get something or post or put, delete we have, and send, they return a boolean. And a boolean actually indicates if a response could be received. Or was received. The boolean does not mean that the response was successful. The boolean just indicates, did you even get a response? So maybe the URL was incorrect, there was no server at that URL, or maybe the URL could not be translated into an IP address, so the DNS is not giving back an IP address for that URL. Maybe the server is just down, could not be reached, did not respond, whatever. There could be many reasons. Maybe it was blocked by a firewall, you don't know, but he could not reach that URL, he did not get a response. So you should always test that one, always test, did I get back something? Now, in case of a false, meaning I did not get back a response, you should also test the property on the response message is blocked by environment. The little strange thing here is that there is not even a response message at that point. I mean, there's no content, no headers whatsoever on the response message. You did not get a response. But there is blocked by environment, that is a boolean that could have a value. And if that is false, you need to raise an error with that error message. Is it blocked by environment, or, well, you did not just get a response whatsoever. Now, that blocked by environment is actually something that sometimes annoys people. First of all, it only occurs in sandboxes. So The idea behind it is that you want to control, the user needs to control if an app really is allowed to make an outgoing call. Think about a sandbox that is a copy of a production environment. You do not want your sandbox then go out to real production environments, make calls to them, and place maybe some orders or whatsoever. I mean, this is a real scenario that I've been in. It's a long time ago, but someone was very proud of the integration that they created, that we created for automatic ordering at with a vendor, and they ordered 100,000 pieces of this and 100,000 pieces of that, and literally 1 or 2 weeks later it was beep at the gate, and the vendor was happily delivering the order. That was not really intentional. So you want to prevent that, so that's why in the sandboxes, even if they're copied from production, then all apps are switched off for external HTTP requests. Now there is a record in the table nav app settings, and that is controlling the allow HTTP client request. It's pretty much the only field in that table. If there is no record in that table, then the user will be prompted, what do you want? Do you want to allow always once, or do you want to block always or block once? If you say allow block once, one of the once options, then that table will stay empty, will not be a record for the app that is trying to make an HTTP request. And the next time you make a request with the same app, the user gets the very same answer. If you say always, either allow always or block always, then that table will get a record for the app, and HTTP client request, allow HTTP client request will be set to true or false based on what you do with allow and block. Now, if that record exists, then the user will simply not be prompted. The user will of the HTTP request will just be blocked or be granted, allowed, if that record exists based on that field. Now, in case you say block once or block always and that record is being created with allow HTTP client request false, then the HTTP response message is blocked by environment will be set to true. So then you know, hey, I'm blocked by the user, and you can gently ask the user, hey, please allow me, because I cannot do what I want to do. Maybe that is on purpose. Yeah, that is just how it works. Now, what you need to keep in mind here is that this record can be opened from the extension management page. And when you do so, then it will automatically be created. As an effect, you will not get that prompt anymore. It will just block, unless you say true in that page. When you copy a production to a sandbox, then the nav app settings table will be cleared. And you can also create that record yourself in your code, in your install code, for example, just to self-allow the app for doing HTTP requests. There's also an option. So let me quickly demonstrate this, how that works. So I'm going to have this one. No, that's not what I want. Come on. This is the one I want to open. And I'm going to opening a page for HTTP demo, HTTP request. We will spend some time in this page, in this session. First of all, I go to my extension management page and find my app. It's over here. So this one is now allow for HTTP request. I just pretend that it was brand new. So I delete this record. do you want to delete the record? Yeah, I want to delete. It seems like I'm deleting an app. I'm just deleting the nav app settings record. That's fine. And now if I say, hey, send a request, I get this message. And if I say allow once, that's fine. It's just going to work. Give me something back. And the next time I do the same thing, it's going to give me the same message. And if I say send request allow always, then I don't get the error message anymore. It just works. But if I go to that extension management page, then you see this one is existing here. And if I delete it, I'm back to the beginning. So I get that message again. Let's say allow once, so it's not creating that record. But now I open the page one time, meaning I do not allow here, I just have now the record created, and then it says, sorry, it's blocked by the environment. I don't get that error message anymore. So this can be a little bit confusing how this works, but now you have seen the internal mechanism of that. All right. So here we go, on the next slide. Next slide. So the other thing is, when you receive a response from the HTTP client, then you should test the HTTP status code. Any status in the 200 range means success. There could be 200 OK, 201 created, 204 no content. Anything in the 200 range usually is successful. You can test that with is success status code. Or if you want to test for a specific status, because you expect, for example, 201, then of course test for that on the HTTP status code. But is success status code test if it is in the 200 range. And if that is not successful, you want to show an error to the user, usually with the status code and the reason phrase. Now, sometimes people do have a problem with remembering all the HTTP codes there are. So here is some reminder for you. You can remind them with dogs, if you want to. So, I mean, HTTP status dogs, and they tell you exactly what they mean. I don't think I have to explain what 304 not modified means, this one here, or not found, or whatever. And if you are more into cats, be my guest, there is one for cats too. So, for everybody, something. Okay. Hey, this was, of course, for a little bit of fun, but okay. There we go. Continue this one. So I just demonstrated you that basic pattern, and that is actually what you see here on the screen as well. And then finally, when you have a successful response, well, you can get the content out of the response message. The response message has a content property, which is basically HTTP content object, and you can do a read as, and then read it as a text, or read it as a stream object if you have binary data. Now we have a number of methods on the HTTP client: the get, the post, the put, and the send. And all of them are sending data. Now basically the get, the post, and the put command are basically wrappers around the send method. If you ever ask yourself, why would I use send if I have a get? Or what is the best option to use? Should I use the send or should I use the get? Well, then it may help to know that the get is just a wrapper around the send. What it basically does is taking away some code from you that you don't have to write. So here in the example, you see method 1, which is using the HTTP client.post. So it writes an HTTP content from the request body and then posts it. And the second method is using the HTTP client.send by creating a message, HTTP request message with the method post, set the request URI, write the content, and then send it. Now, if you look at the post method, behind the scenes, it basically does the same thing. Create a request message and then call the method send. So it's just some sugar coating around the send, making life a little bit easier for you. But when you start seriously developing with integrating with web services, you most probably end up with using the send yourself. I mean, that's what I find myself in most cases doing. Now, this is the basic pattern. Let's look at HTTP headers. HTTP headers are used for additional information with a request or a response. And we have different header types. And you probably are already used to the term request headers and response headers. But we have also something called representation headers and payload headers. That's actually the official naming from the official definition of headers. I will come to that, of course, I'll explain what is the difference and what are they used for, and you probably then say, oh, but representation headers is... No. You combine headers, or you have that as a set of headers on a request or a response. Some of those headers can have multiple values, some of them cannot have multiple values. For example, you can have an accept language header, which can have multiple values, so I accept English and German or whatever you have as a language available for me. But the content type header can only have one value, because your content type is just one type. It cannot be two types in your content. So based on the header, it is allowed to have one or more values. And that is something that is defined and actively checked. When you set a header value, that is, and you try to add another value to it, it is checked, is this allowed for this header type? If you want to see or read, have a good read about headers, I have a link here, Headers for Dummies. At least that helped me a little bit better understanding of headers, or if something is not clear, I can refer to that page. It's actually pretty good read about headers. So, request headers, what do they include? They include, for example, I mean, these are just examples, there could be more. A user agent, which could or is used for indicating what is the HTTP client actually, what application is it? Is it a browser? Is it another application? What is the version of it? Usually used for statistics. Sometimes also used by a server to know how should the response look like. But in most cases, just for keeping statistics. The Edge or the Chrome browser is used the most, or what all browsers you have. So that's it. But also for versions. So, for example, server could say, sorry, you are on an older version of a certain application, I cannot help you. The host header is usually the header that indicates the actually part of the URL, where are you sending this request to. Accept language, and there are more accept headers, used to give an allowed or preferred format of the response. So I would prefer to have data in English or German or whatever language, and I accept encoding in gzip or deflate or whatever. Authorization is also a header request that is going on the request, of course, and authorization actually is the wrong word here. The header name is authorization, but in fact it contains authentication credentials. It does not authorize you, it authenticates you. It's up to the server to give you authorization based on your authentication. Okay, the header is called authorization. It's what it is. So these are examples of request headers. We also have response headers. Usually we see a header with the server name, so is the server an Apache server or maybe IIS server, or, well, just the name of the server that gives you the response. There could be a location header. Usually the location header is in combination with status code 301 or 302, meaning, hey, I do not have this resource anymore. You are redirected to another location, and then the location header defines where you should go to. HTTP client is predefined to follow that location in that case, so it makes a new request to the location. We cannot switch that off in the HTTP client in .NET. That would be possible, but not in AL code. But we also see the location header, for example, in Business Central APIs, and we call a bound action. It could return a location header where we can find the updated record that was created with the bound action. Cookies could be returned, but many servers use that, of course. And then the idea is that on the next request that you make, you also set the same cookie. So you have a kind of a session ID that the server knows, hey, you made a first request or a second request, or I know who you are. It could be an authentication value. It could be something that is used for authorization. It could be used for transactional stuff. And it's up to the server how it wants to implement the cookies. Then we have the content headers, and that is actually what is officially named as representation headers. Representation headers are about the content, and they can both be in the request and in the response, of course, because you can send content, you receive content. Just the content type header, the content encoding, content language. So content type could be application/JSON or text/plain or application/XML or PDF data, all the MIME types you could have in there. How are they encoded? What's the language that is in the content? But only part of the request or the response if it really contains data. In most cases, what we do from our code is only set the content type. We do not really care about the content encoding or language. Usually that is not our concern. And that content type, as I will also demonstrate later, is only available on the HTTP content object. If you try to set this on the HTTP client directly, you will get an error message, not allowed. HTTP content is the object that you use to set the content type header. No other object except the content type header. That is not because AL implements that, it's because the .NET objects behind HTTP client and the HTTP objects are defined in that way. Then we have the payload headers, actually also about the content, but it's more about the content length, the actual length. It may be a range if it's being sent or received in chunks of data, and some encoding about the transfer. We usually do not care about these. It's all calculated automatically for us, automatically added by the HTTP client. So we do not care about the payload headers. Now, how do we work with the HTTP headers? We have an HTTP headers object, and we use that to add a name-value pair. And the name-value pair is used to create a new HTTP header if it does not exist, or if that header already exists, it tries to add the value to the existing header. So then we basically create a header with multiple values. But some headers do not support that, so in that case you will get an error message. Now that value, that is usually a text, but it could be a secret text, especially when you're working with an authorization header and you want to add a token or use a password combination, then you should use a secret text so it cannot be, at least it's not visible while you're debugging. Now the point is that in the request itself, it will just be plain text. The request itself is not a secret text. You can sniff it, you can see it, as long as you have, of course, the SSL certificate that is being used on HTTPS communication. Never, ever use HTTP without SSL when you are exchanging authorization information, because then anybody else could sniff the data and get access to tokens or passwords or whatsoever. Now there is a little bit strange thing going on with the HTTP header object when it comes to secret text. We have an HTTP headers.keys which give you that name value, the list of all the names, which is both text and secret text. I mean, the name itself is not a secret text, it is the value, so it gives you a list of all the keys. But if you try to get the values of a certain name, that is the third option on the list, then you ask for the values of a specific header, and because it could be multiple, you have to request for a list of text. If that was a secret value, then get values is going to give you an error message. In that case, you need to use get secret values. But there is no function that says, get me the secret keys, or the keys for the secret values. So the only thing that you can do there is ask for contain secret. And then you know, hey, is this a secret or not? A little bit more information about this, too much maybe, but just saying that if you sometime want to read the header object, you may run into this, and then hopefully you remember this. Usually you do not inspect the headers object anyway on the request, and on the response, it's always text. How would AL know if a certain response header should be a secret text or a normal text? So response headers are always normal text. How do we add request headers? Now, and here's the confusion for many people. We can add them on 3 different levels. We can add them on the HTTP client, we can add them on the request message, and we can add them on the HTTP content. And this is also related to if you are using get and post, or you are using the send command. Because if you are using get and post, then you are not using HTTP request message. So you're not able to set headers on the request itself. You can only set them on the client or on the content in that case. But if you are using the send, then you're also using the HTTP request message, and then you can set them on all 3 levels. So how do we set them on the HTTP client? That is the default request headers function on the HTTP client. That returns an HTTP headers object, and the easiest way to use that is just say HTTP client.defaultRequestHeaders.add name value. When you do that, the name default request headers already has it in it. That header will be added to every single request you do with the same HTTP client instance. You use that for static values like a user agent or static credentials like basic authentication. So let's switch to a small demo about this. Go in here. So what I'm doing here in this piece of code, I have an HTTP client, and I set default request header one time, and then I do a first one, HTTP client.get, and a second one, HTTP client.get. Just actually 2 times the same request. And then when we inspect the request, you will see that they both will have the same user agent. So let me find that demo again. And I'm going to use this one as my tester. Here I can actually see what is coming in. Let me clear all the events. There we go. And default request headers, the first one. Failed to get a response. Okay, that's funny. Why was that? Of course, it usually always works, and now today, trust me, it works. I mean, you remember that phrase? Why is he... Oh, there's not anything here. Okay, that's funny. Let me quickly see if I can find what is going on here, because if this is not working, then nothing is working. Let me quickly check. Demo request headers on line 10. Yeah, okay. Maybe I don't have an internet connection. It could be blocked, but as far as I know, well, let me check. Maybe you are right on that. That will be the first thing to check. Oh, could be the case. Maybe it's as simple as that. And now you know why it is important to check is blocked by environment, because then I would immediately know. Probably my code, let me check. Ah, my code didn't have it. It was on purpose. Of course it was. Okay, there we go. It needs to wake up. There we are. And here I have 2 requests coming in. Let me check the headers. Here I have a user agent on the first header, Business Central version 24.1, and the second one has the same header. And all because I set it one time as a default request header. So it is added to both of the requests. The next thing is adding it to the request message. And, well, only when you want to do this, you need to use the get, the post, you need to use the send and not the get, post, or the put. You can set the HTTP headers request on, the header on the HTTP request message, not directly, not in the same way as you can do on the HTTP client. On the HTTP client, you had that function, get default request headers. And then you could say .add. There is not an HTTP request message .headers.add. Because somebody at Microsoft thought it what might be a good idea to have a get headers function that returns the HTTP headers as a by var variable, by var parameter. I mean, I don't know why. It returns a Boolean if it was successful or not. I never ever come across the situation that the Boolean is false anyway, so, okay. It would be lovely if Microsoft would just say, hey, we give you an HTTP request message .headers that actually returns headers. Otherwise, the code is a little bit more clunky, as we'll see in the next demo. Now, headers that you add on the HTTP request message will only be included with that particular request. The next request will have an empty set of headers. Only the default request headers from the HTTP client will be added. So the HTTP client actually combines the headers from the default request headers and the headers you set on the request message. They will just combined to one list of headers. Now you use the request headers with expiring tokens, for example. So you don't set them as a default because they can expire. So every time for every request, you need to see if you need to specify another token maybe. The accept headers. For this request, I accept a certain language or JSON or XML or whatsoever. But you cannot use it for the content type header. If you do that, you get that misused header name message. I'm sure many of you have seen this one and then wonder why. Well, the content type header is not on the request. You will see that when we talk about the HTTP content itself. So let me show you this one as well. And that is this piece of code. Here I still set that default request header. And then I have a request number 1. I set a method to get. I get the request URL. And then I get the headers. And on the headers, I set 4 different extra HTTP headers for this request. I set my accept, set the language, and I have a custom value, not customer. Oh, I always make that typo. The custom value 1 and custom value 2. Now, on the request number 2, I clear the request message, and then I add accept XML and accept language, but not the custom headers. And that's it. So let me publish this one. And there we go. Request message headers. So here's what we get from the first one. In the headers, we have my custom header. Now look at this one, custom value 1 and custom value 2 as one header. You see, my custom header is actually add 2 values to it. So it comes in as as one header with 2 values in it. And I have my user agent as the default request header. And of course my accept language and accept application JSON. When I look at the next request, done with the same HTTP client but with a different request, I have accept text XML language, but I do not have that custom header value anymore. So that is how we can manage the headers that are sent with every request and the headers that are only sent with a particular request. Pretty simple, isn't it? You just need to know how. All right, so this is about getting stuff. Let me get to the HTTP content. The HTTP content is used to transfer content, either in the request or get it back in the response. You can set the content in 3 different ways. You use write from a text variable, or write from a secret text, and then write from an in-stream. So there could be an in-stream from a temp blob, for example. Now the content type header, that one will always exist, even before you write any content. With a default value text plain. That's hard-coded. Simply hard-coded. Now the question is, why does it exist? Because that is something that, if you understand why that actually happens, it makes your life a lot easier. The HTTP content, when we look into .NET, then for those who know .NET, I'm not opening it, I'm just telling you, the HTTP content object in .NET is an abstract object, meaning that it is an object that you cannot instantiate. You cannot create an HTTP content object. The only thing you can do is create one of the derived types. Derived types in .NET means an HTTP string content, or an HTTP stream, or an HTTP... different types of HTTP content. If you create in .NET an HTTP string content, it will have a value text plain on the content type header by default. Well, this is what happens behind the scenes, because in AL we do not instantiate .NET objects. We do not instantiate those wrapper objects that are actually .NET behind the scenes. HTTP content is just .NET HTTP content with a wrapper layer around it. We do not instantiate objects in AL code. We do not. So for that reason, the AL code behind it, actually the .NET code behind AL, has to instantiate that object for us, but you cannot instantiate HTTP content. So they're instantiating the string content with text plain as the default header. So as soon as you define HTTP content, now you know that in the background you actually have an HTTP string content with header text plain. That is why it happens. Now, as soon as you do a write from text or a write from secret text, that means that you're actually creating another string content. Actually, he does that for you in the background, creates a new HTTP string content object, resetting the header to text plain. Even if you changed it before the write from, it will be changed back to text plain. Meaning that you always need to set the content first and then set the header content type, not the other way around, because then you may be in trouble. So first do the write from, then set the content type. But hey, if we set the content type, we're actually adding the value, to the already existing content type. That is not possible, because the content type can only have one value. So you first need to remove it, and then add it again. So that's why, just what happens behind the scenes. Let me switch to a demo. Some code. So here we have the correct order. I do a write from response text, then get headers into a object HTTP content headers, then I remove content type. It is always there. If you want to be 100% or 110% safe, you do a if HTTP headers dot contains content type, then remove the content type. I mean, that would be 110% safe, but you are already safe with this piece of code anyway. And then you add it. If I forget about this, this line is going to give me an error message. So let me quickly show that error message so you remember that one. Come on. Did I actually? That's funny. Oh, sending content. Of course. I'm trying to do the send. Yeah. Oh, I actually did not. Let me try it again. No, probably. Did I not publish? I thought I published it. I probably did something to the code. Anyway, you will get an error message, that's your ID. Again? I don't understand what you say. You think it is demo 5. Let me check, otherwise we just continue. Oh, that, yeah, of course. I was just clicking on the wrong demo. Sorry for that. Cannot add the value because content type does not support multiple values. That's actually a message. Thank you. I don't have T-shirts at the moment. Hopefully they will come in before the end of it. You really, I owe you a T-shirt. Anyway, so this is the message, and the way we solve it is by clicking on a different demo. No, just remove that content type header first. Okay, so now it works. The funny thing with this code is always that I have to think about it. I do a get headers, HTTP content headers, and then I set on the headers, I do some actions on the headers. I'm not doing a set headers. That's not required. It's like I get an object out of HTTP content, I do some stuff on it, and then I don't have to push it back into the HTTP content. That is because of .NET and reference objects, etc. I'm not going into the details, but it's not needed. It does not require it. Okay, that was that one. Let me. Next. Something about performance. Creating a new HTTP client instance is 90% slower comparing to reusing an HTTP client instance. What do I mean with an HTTP client instance? A variable of type HTTP client. As soon as you define that variable, you run the code. If you have it as a local variable in a function, the moment you call that function, the HTTP client will be instantiated. And what I did is I just compared the code with a local function. A function with the HTTP client as a local variable, and then setting the default request header, versus a global variable with HTTP client in the same code unit, and then calling a function that only sets the request header. And the time it took was just 90% less for working with the global variable. So does that mean that you always should use an HTTP client as a global variable? No, that's not what I'm saying. What I want to say, because even if it is 90% slower, I had to run it about 10,000 times to even get into something measurable, like 7 seconds versus half a second or something like that. The point is that if you are going to do a 10,000 times a call to an external web service, maybe because you want to synchronize something, then the cost to create an HTTP client instance for every single request is measurable. But on the other hand, the request itself is considerably slower and you will probably not get any faster on and better performance, because it's the request itself that takes probably 500 milliseconds or maybe more to complete. So for the performance of your process, it does not make a lot of difference. However, HTTP client instances in .NET are meant to be long-lived. That is how they are designed. There is actually another reason, and if you are from the .NET world, you probably know about this and maybe have wondered how does that work in AL code. The expensive part of the HTTP client is something that is internal in the HTTP client, that is called the HTTP message handler. You never seen that one in AL. You will not. But in .NET, it is definitely a thing. The HTTP message handler is actually handling the transport, the sending the request. Now the point is that every HTTP client with that HTTP message handler is keeping a connection pool. And the connection pool is, let's say, an open port to an outside server. Now, if we think about .NET, the problem in .NET is that if we instantiate an HTTP client for every single request, and we do not even think further, then he will open another port and another port and another port to the outside web server. And that port will not be closed when the HTTP client goes out of memory, when the HTTP client is disposed. Because that HTTP message handler in the background lives longer. It keeps the port open in a connection pool for 4 minutes. And that is 4 minutes because it's defined in the official HTTP specification, or TCP. So, because of that definition, and 4 minutes open port, that means if you run that at 10,000 times in a minute, you end up with 10,000 open ports on the server. Now, imagine that a couple of users do that, and you suddenly have 30 or 40,000 open ports at the same time. You see where that one is going? At some point, you run out of available outgoing ports, because there is not unlimited. It's about 65,000 ports, outgoing ports. So, you run out of ports, and that is known as port exhaustion. In the .NET world, the HTTP client and port exhaustion is definitely a thing. And if you Google on that, you will find a lot of information about it. So how does that work in AL? In AL, it is managed for us. It is, in the .NET, you can work with the HTTP client factory. HTTP client factory creates a new HTTP client for you, but pulls or caches the HTTP message handler with those open connections, so it can be reused every time. And that HTTP client is meant to be short-lived, because it's the message handler itself that it actually takes the time to instantiate, that has the connection pool. And AL handles all of that for us. Why I'm then telling this to you? Because if you are comparing .NET, if you are into the .NET world, if you have maybe read about it, you may wonder, hey, how does this work in AL? Do I have this problem in AL? And actually you do not, because the team of Business Central already figured it out that their service would pretty fast run out of outgoing ports if they didn't do anything about it. So there was probably a matter of teaching all AL developers to do it in a proper way, or do it themselves. Well, luckily they chose to do it and manage it themselves. So internally there's an HTTP client factory, and in case you wonder, in case you have you know more about this, they are using a delegating handler behind the scenes. Not going into details, just saying. So that's short-lived. That means something. Because does that mean that we can just instantiate the HTTP client every time? So have it as a local variable in our functions. I just said, even if it is slower compared to having a global variable, the request itself is probably taking more time, so it's not really measurable when you make external requests. So what is the better option? So let's look at some best practices here. Every instantiated HTTP client requires initialization with some default request headers or authorization headers, etc. Now it is okay, this is my recommendation, it is okay to create a new HTTP client for occasional requests. So requests that just happen every now and then, like you do an HTTP request to check I don't know, a license every hour or something like that. But if you have a loop, for example to synchronize data, to send multiple records, you should rather have a code unit with a global variable for your HTTP client in it, and then initialize it one time, and then make the request multiple times, and then let the code unit go. You could even put it into a single instance code unit, but then you may run into another problem, because that HTTP client will be sitting there with its HTTP message handler, and it will when it has made a connection, it knows the URL, it knows the IP address, it will never ever pick up a DNS change, unless the user logs out and logs in again. And DNS changes, well, they happen. So if the server is sitting at a different IP address suddenly for whatever reason, then, hey, the HTTP client is not picking it up. And in .NET, you can set a connection lifetime, pooled connection lifetime. So after this period of time, you need to refresh your DNS stuff. We cannot do that in AL. So how does that look like in code, this recommendation? We go into this one here. This is actually what I usually do. I have an HTTP client in a normal code unit as a global variable, so not a single instance code unit. Then I have a function for example, send request, and in the function itself, which I actually could also put in the send request, but anyway, I have an initialize function, and then in the initialize, I do one-time initialization of the default request headers, and then every other request that is sent through the same code unit will have those headers, but it does not have to instantiate the HTTP and initialize the HTTP client again. By doing so, I mean, you're not really gaining a lot of performance for your requests, but at least you put the server at ease, because otherwise the server has to do the heavy lifting of creating that HTTP client every time again. So we're actually relieving the Business Central server in that case. And if we all want to be good neighbors, especially in the SaaS world, we should just follow this best practice. So this is how I usually work with the HTTP client. Again, global variable, multiple functions in it to send the requests. Okay. Then I showed you a lot of code around sending requests. Now, in version 23, the REST client module was released as a community contribution. I wrote it. And this one is meant for encapsulating the HTTP client and all the other HTTP objects. You can call web services with just one line of code. And the whole stuff about, is it successful, is it blocked by environment, all these lines of code are inside the REST client. So here are some examples. Getting text, basically REST client.get, and then on that get, we get back an HTTP content code unit, get content, and I can say as text. That's it. Posting text is as simple as posting to a URL and then call on the HTTP content object a create with the text and application says JSON in this case for the content type. So we don't have to set a content type header ourselves, and we can then do get content as text. Or if we want to work with JSON, get as JSON returns a JSON token. So the only thing I have to do is say as object and get back a JSON object directly. Or post as JSON, pass in a JSON object. We don't even have to create HTTP content, that will be handled for you. And it returns a JSON token. That could be an array, that could be an object. That's up to you. You know what's going on there. And then you can cast it into an object again. Alternatively, what we can also do, if we want to have the text, we post it as a JSON with the JSON object. And then, because we get back a JSON token, we can write it directly to the response text. So, turning it into a text rather than JSON. Can store it directly to a field, I don't know, whatever. Another alternative would be this one, post HTTP content create as the JSON object. So here we see HTTP content create with a text. Here we see an HTTP content create with a JSON object. You don't have to think about the content type because it knows this is a JSON object, so the content type is going to be application JSON automatically. And then get the content as a JSON as an object. Well, you see, post as JSON is actually doing that get content for you. Returns actually get content as JSON for you. We can also have binary data. We can get content as blob and returns a temp blob code unit. Or the other way around. Post it as a temp blob and then say, hey, there's a PDF that I want to post there. So it makes life a lot easier. So a lot of objects in there. We have the REST client itself, which actually is then the replacement for HTTP client. We have an HTTP request message and response message code unit, a content code unit. We have a method enum, and we have a client handler. I will focus on the client handler in a minute. And we have also an authentication interface for BASIC, for OAuth client credentials, and I'm working on extending that to all OAuth types. So the REST client is part of the system application. That also means that if you are using the REST client, you will get a question. Do you allow the system application to make a request to an external server? That's maybe not what you wanted, because the system application should not get global permission. Imagine you have multiple apps making use of the REST client, and app number 1 is making an external request, and you say, yes, system application may make that request. Then app number 2 comes in, but because the system application where the REST client is in has already the permission to make external request, app number 2 is allowed automatically. That is a little bit of a horror, right? You don't want that. What is more, telemetry will not be sent to your app insights, because it will be sent to Microsoft, because it's the system application that sends the requests. So that REST client, I'm going to demonstrate this, needs to be a little bit smarter. So let me go in here and show you the REST client. You see here, extension system application. That is actually what he's now asking. And if I say yes, I open it for any app that is using the REST client. Do not use it in this way. Actually, maybe I should just remove this option and not let the system client do the actual request. If you agree, tell me. There's one person at least. Okay, can I get a hand? Who agrees that I should remove this? Well, that's not everybody. So wait a second, I'm going to demonstrate you how to solve this and the pattern that everybody should use in their apps. And if you are then still agree, I may suggest to Microsoft to remove it, but it's probably not going to happen because it's a breaking change then. So, what is the point? Let's see if there was actually on the slide. Yeah. What you should do is you should use the HTTP client handler. HTTP client handler implements the interface HTTP client handler, and you use that one to initialize your REST client. So here on this code, this is my code unit, and that code unit has one function in the interface. The HTTP client handler has one function interface, and it is sent. And it provides you with the HTTP client, the request message that needs to be sent, and the response message that needs to be returned. And it only needs to have 2 lines of code. HTTP client.send, returning the response message, and then pass that response message into the code unit. This is all you need. But now it is your code that is performing the HTTP client.send. Your code. And this makes it so powerful, because now your app will be asked if you want to allow outgoing requests. And telemetry is going to your app and not Microsoft. And what you need to do is, on the REST client, initialize it with that client handler. That's all. So you define that one time and use it on initialize. So let me do that. Do I have... Come on. Now I have nothing on my screen. Well, this is not what I was looking for. So, technician, what can I do? Okay. I'm going to do like this. Come on, I can watch that. The big screen over there. And take that one. So this single line here, just gonna uncomment it. And then go here. Whoa. And then do it once again. And no comment, no ask, no question. So let me really verify that it's my app that is doing this. Extension management. Go down. Delete it. Do it again. There we are. So this proves that by passing in that client handler, it's my app that actually makes the call. So this is something we should all use instead of just using the REST client out of the box. So again, the question, do you agree we should force everybody to use this? Not everybody here, still. Okay, I'll discuss that with Microsoft, if that was just a good idea or not. This client handler also allows you to test without making the actual call, because you can mock the results. So here is the same HTTP client handler implementation, but now I call it my test HTTP client handler. And instead of making the call, doing HTTP client.send, I just set the status code, the response phrase, the JSON object that I want to pass in, and say success is true. So I've completely faked the response. And with this way, I could say, this is a positive one, maybe I want to have a negative one as well. How do you react? How does my code react to a status 404 or to an object that is invalid or whatever? There's a lot easier to test your integration with external services than actually making the request and then make sure that that external server is replying in a correct way, in an incorrect way, with an error message, with an invalid object, etc. You just fake it, because your test your code, not the external server, right? So this message handler or client handler is not only to get everything into your app, it is also the way to have proper tests for your external services integrations. All right. Do you like this REST client? Good. Thank you. It's so a lot easier now. Okay. There is more. I mean, I can talk maybe for half an hour about this REST client, but that's not what I want to do. Final couple of minutes. I want to talk about the next piece that I'm working on, and that is actually a combination of endpoint and OAuth. It's under construction, and the idea is that we can have an endpoint configuration. You can also do it completely from code, but an endpoint configuration in Business Central, where we set up everything, kind of similar to the app registration in Azure, but now the client-side part. And then the only thing we need to do in the code is to say, hey, REST client, this is the endpoint, and it configures it completely with everything that you need. Let me see if I still have a black screen. Yeah, I still have a black screen. Okay. Not really funny this, but I'm trying to get my way through it. Where is my mouse? I'm happy to have big screens there. So this is how it works from a code perspective. I have a REST client that I need to initialize. Let me go down. Where is it? It's here. Initialize with an HTTP endpoint code. And then what I do is I call this one HTTP endpoint.get REST client. The bind subscription around it is to pass in the client handler that I just demonstrated. But this get REST client, that's actually what you need. And when we do that, we get all the settings that we need. So let me open the endpoint definition. So here, I'm going to call Business Central from this endpoint. This is my base URL. And I specify that I want to use OAuth authentication. And I tell him that my OAuth authentication is using Microsoft Entra ID, that my OAuth application is the BC. Let me go into app registrations. Here's my BC definition. It does have a client ID. It allows multiple organizations, meaning it is multi-tenant. It could also be single-tenant. And in this case, it's not having any secrets. I'm using a certificate code. And the certificate code, let me just do the drop down here. Full list is this one. That was not what I wanted. Select from full list. Yeah, to show you the card page. Anyway. Entra certificates, there we are. So this is my certificate. I could even create a certificate from this code. So if I go into Azure Entra ID and I create an app registration, then you can choose between secret or certificate for the authentication part. Secrets are used for test and development. Certificates should be used for production environments. But how do you get that certificate? You don't have to buy it. You just, this code is actually creating that certificate. You can download it from here. You get the public key. The private key stays in Business Central, never leaves Business Central, because it's only used to sign the request, not to be transferred to Azure. And the public certificate, you upload that to Azure, and that's it. And you can see this one expires on 2099. Well, that's quite a long time. Maybe it's not the best option, but secrets expire at least every 2 years. Certificates have an expiry date that you can set. And it is safe to have that 10 years or 20 years because it never ever leaves the application. It is not transferred over the internet anyway. I'm not going into the code how to create a certificate. That is a different topic actually. So I have my app registration here with the client ID, and instead of a secret I'm using a certificate and a redirect URI, which is different from the standard URI that Microsoft is using. Different story, not going into that. And here on my endpoint definition, I tell him which Entra ID I really want to use, and if I want to use client credentials or authorization code. I stay with client credentials for here, and I tell him the scopes. You probably remember that one also for your app registrations in Entra. Client credentials always require this scope, the /.default. So how does that work? After you have set that up, again, if you have done Azure app registrations, you will recognize all of this. So let me open my test page and tell him that I want to make the request on that BC endpoint. Let me see, do I get something here? No. Oh, it's not even making a request now. Oh, that's funny. Oh, it might be blocked. It might be blocked. Yeah. Hold on a sec. I need, because I published everything, was not really working as I like to. Yeah, it might be the blocking issue here. So let me go into extension management. I actually should get an error message about blocking, but let us check. It is allowed. So that cannot be the issue. Okay, so somehow it worked when I tested this yesterday, but trust me, I would have a list of companies here. So let's not fix that on stage. If you will be interested, you can contact me. The idea was, crap, this should have worked. Anyway, I'll stop this demo here. And switch back to my slide. So, endpoint configuration. Oh, one more thing on this. Because this is all configured in the client, you can also do it in code completely. And you would have code like this. Client application, set a client ID, set client secret or a certificate, set the redirect URI, add some scopes, initialize your grant flow, is it authorization code grant flow or client credentials, and then initialize it, and then, well, you can get a REST client with that. So just, you can do all of this from code. This part is under construction, honestly. So if you think this makes sense, then also let me know. That was actually the last slide. So 10 minutes left for questions. Again, I don't see any t-shirts. They were not delivered. Sorry for that. Maybe somebody's bringing them now, but there are no t-shirts. No, sorry for that. But here you go. Sorry, Milan. Yes, sir.
Hi. Yeah, in the beginning you spoke about the sessions being blocked, and yeah, we have seen multiple occasions of that. But I've seen multiple times when I try to use the HTTP client on Docker that it doesn't work. I don't know why, but I realized just by restarting the Docker, it suddenly works again. So is that something you have experienced, or?
It could be a Docker issue, because Docker and networks and blocked by firewalls maybe, that could be an issue.
Yeah.
It depends on how you create your Docker, if you add it to a internal network, or, I mean, these things can happen. That, yeah, it's not usual, actually. I never run into that, what you were saying.
I have had it on multiple occasions during different times of year and so on. So that could be a tip. Just try and reboot.
In that case, you should actually look into how you create a Docker containers. I think. Yep. Right. Should not do that.
My question is, with the addition of the REST client,
Yes.
is there any purpose for the HTTP client still?
What do you mean with purpose for the HTTP client?
Is there anything I can't do with the REST client that I still need to use the HTTP client?
Yeah, it is using internally the HTTP client. And at this moment, the REST client is not supporting the cookies. So that needs to be added. But as far as I know, that's the only part that you cannot use the REST client for.
I see.
So the REST
so
client
I'm sticking with the REST client for now.
Yeah, you can use the REST client for pretty much everything. There was a question over here? Yeah?
Is the REST client limited to cloud or is it also on-premise?
On-prem as well.
Okay.
Yeah, absolutely. Do I see more questions?
So with your last demo on the Entra ID apps
Yeah.
and stuff, so that's you do plan to make that as an open source contribution?
Yes, that's the idea.
Authentication types, enum extensible?
Yes.
Perfect, thank you.
Yeah, absolutely. So, and interfaces around it, yeah. So it is under construction, so that's my excuse that it doesn't work. It did work yesterday when I checked everything. Sorry for that. If you stay around for a few more minutes, I could try to fix it right after to make sure, if somebody wants to see it. But yeah, it's under construction, so that's my excuse. Any other questions?
I actually had a question about that poor Postman you used for tests. Is there any plan to make it as an app? Because there's something that many non-technical people asked for tests and so on. And is it possible to make it similar to the real Postman somehow?
That's why I named it My Poor Postman. It is actually just a viewer, a controller in where I can show JSON and XML and whatever right into the client. So yeah,
A custom control in? That one with the code lines?
It is the ACE editor, and yeah, I can make that available, of course.
Okay,
it's
thank you.
quite powerful, but I think I should create a small. Let's go. Maybe I should make a small blog post about that separately, and then give the source code away on my GitHub. I put it on my list.
Is it possible to add logging to the REST client? Can I hook into the interface somewhere that I want to?
Logging, yes, because that client handler is giving you everything.
Yeah.
So you could use that for logging, if you want to. In the first edition that I created, I had a logger, actually, but then somebody told me that might not be a good idea because of GDPR rules, or you could expose data that you don't want to expose. So you have telemetry, of course, with outgoing requests. Everything is there, reducted for private information. But for debugging reasons, I could see this happening.
Yeah.
So yeah, definitely possible.
Okay.
More questions? No more? Well, in that case, I have one final slide. Thank you.